Okay, today we talked a lot about, well, a little bit about angles and how to measure angles with a protractor. And um, what I want to do right now is just talk about how Eratosthenes, back in 240 BC, used measuring angles to figure out the circumference of the Earth. First of all, I want to say that a lot of times you hear people say that people used to believe that the Earth was flat. And here you have in 240 BC, like I said, 240 BC, you have a man who is measuring the circumference of the Earth. He's figuring out how far around it is if you went all the way around the Earth. So clearly, educated people did not believe the Earth was flat. That's something that was not widespread. So that's important to remember. So Eratosthenes, remember that name, he's very important. He lived in Alexandria, here right up at the mouth of the Nile River in Egypt, and he was the head of the library in Alexandria, which I don't know if you've learned about it yet, but it was a very important place, and it was a very special place. If you went into Alexandria, you had to give up your books. They would take your books and make copies and put them in their library, and then they would give you back the copies. They wouldn't even give you back your books. So it was a very special place where you could go to find any book you might be looking for. And back then, when books were very rare and expensive, it was a pretty big deal to be head of that library. But Eratosthenes was super smart, and he knew a lot about geometry, and so he used the knowledge he had to figure out the circumference of the Earth. And I just want to show you how simple his idea was and how it worked. All right, so first of all, he lived in Alexandria, and you can see that's here on the map. And then down here, it was a place called Syene, and it's now called Aswan, but it used to be called Syene right there. Oops. How do you spell it? Syene. E-N-E. Right here. So he knew that it was 500 miles from Alexandria to Syene. And so they figured that out by seeing how long it took a bunch of camels to go, how long it took them to get there. I mean, so it wasn't as accurate as we can get today, but he figured out that it was about 500 miles, and he didn't use miles, obviously, but he used stadia. But we're going to use miles just to kind of understand where we're coming from. So this is my picture of the Earth, round, and this is Alexandria here. So here is Alexandria. And here is Syene, or Aswan now. And he knew that it was about 500 miles between those two places. And he also knew that on a certain day of the year, that when the sun's rays hit the Earth, they would go straight down a well in Syene, and there would be no shadow cast, because Syene was on one of the tropics, and on a certain day, which was an equinox, I'm not sure what day it was, the sun would hit at exactly a right angle to the ground. So if you had the sun's rays coming down here, it would just be, whoop, that didn't come out very well. I want red, and I want it to be a line. Let's see. It doesn't want to work for me, does it? Okay. Okay. Go away. Alright, look, I'm just gonna have to make the colors black. Anyway, the sun's rays are obviously not black, but alright, that's not very good. Let's go back. Okay, so I'm just going to start from the center of the Earth, because that way it'll be right. Alright, so the sun's rays are coming down. Golly. Alright, let me fix this problem. Okay, so sorry about that. All right, so these red lines are the sun's rays coming down to Earth, and they're all parallel to each other because the sun's so far away. They're just all going to be coming at the same angle and hitting the Earth at the same in the same way. But depending on where you are on the Earth, it's a different angle. So if you are here in Syene, like I said, it's going straight down that well. It's hitting the Earth at a perpendicular. There's no shadow. But if you're up here in Alexandria and you've got a pole sticking perpendicular to the ground, sticking up out of the Earth, you can see that the sun's rays are hitting it at a different angle. And if you were over here, it would be even a different angle. So it depends on where you are as far as what kind of angle the sun's rays make with the Earth. So he knew that it was going straight down the well in Syene at that particular time, and he was standing there in Alexandria. He put a pole in the ground, and he measured the angle between the sun's rays coming straight down and his pole, and it turned out to be about 7.5 degrees. And so he knew that because if you thought about his pole going all the way to the center of the Earth, and then you thought about the sun's rays that were going down that well coming all the way to the center of the Earth, that they would be hitting the line in the same angle because these are parallel sun's rays. So they would hit his line again if it went all the way to the center of the Earth, still at a 7.5 degree angle. So he said, okay, so that's 7.5 degrees, this central angle, and that covers 500 miles on the surface. What if I went 360 degrees all the way around? How many miles would that be? That's the question. What is the circumference? Okay, so he set up a ratio, and he said, all right, if it's 7.5 degrees is 500 miles, and he didn't use miles, but, then 360 degrees all the way around would be how many miles? And then he cross-multiplied and did the algebra, or however he did it back then, and he came up with about 24,000 miles, and that is very close to what we say today, which is 24,900 miles. So even though he had to do a lot of approximations, and he had camels instead of cars, and he had their approximation for pi wasn't as good as we can do now, and just all this different stuff, he was still able to figure out the circumference of the Earth. So the Earth was that big, and if Columbus had thought about it, maybe he wouldn't have made the mistake of thinking that it was going to be so easy to get from where he was going to the West Indies if he went the other way, because he would have realized the Earth had to be bigger and there must be something in between. So Eratosthenes lived in Alexandria, head of the Alexandria Library, 240 BC, figured out the circumference of the Earth. And he did a lot of other things in math too that you'll hear in other classes probably. You might hear more about him in geometry. But keep that name in your mind, and that's all I have to say about it.